to bring a Gaussian some surface here. I'm going to bring a Gaussian surface. First, come for this. So this is a Gaussian surface. So where surface? It's like a spherical shell. So what it is? Gaussian surface. I'll call it as a shell. Spherical surface or a shell. Is it okay? Gaussian surface. So I'll kept exactly and where the point charge is at the center of spherical surface. Now I'm asking you how many lines of force. Some student may say 100, some student may say 1000, and so just like better to instead of asking how many lines of force, better you ask how many. What is the electric flux? What is the flux through the surface? So definitely, what I can say that the flux through a surface will be equal to how much? It should be equal to this is a point P. What is the flux through the surface? That should be equal to charge. Let me take the charge Q. So how much of electric flux through the surface? So Q by epsilon naught. What is the flux through spherical surface? Q by epsilon, charge enclosed by epsilon naught. That's what the Gauss is telling. So nothing but this will tell us the number of lines of force. So I need not to count what is the electric flux through the surface, charge enclosed by the epsilon naught. So how you should interpret electric flux through the spherical. What is the electric field strength at point P? We know the electric field strength at point P. What is the thing? So it will be radial output. Can we say about electric field strength? So let R be the radius of this circle. What is the radius of this? Let it be R. So what is the electric field strength due to point charge? KQ by R square. Will I agree? Just do make notice. Okay, let's come for this one. Now I have another situation. What I did is like the charge is not at center. Are you noticing? The charge is not at center. It is just shifted away from the center. The point P is, I'm not going to disturb the same point P as it is. One arrow is missing. I'll introduce that arrow. Yeah. Now you can see this one. Tell me, like, what is the, again, the same spherical surface? What is this? The same spherical surface it is. What is the flux through the spherical surface? How many lines of force were here passing? The same number of lines of force will pass through this surface. So what is the flux? Will remain same. No change in the flux. But look at the point charge. Earlier point charge was at center of now what about point charge? Point charge not at center of spherical surface. No. What about the electric flux? Still it is Q by epsilon naught only, irrespective whether the charge is present at the center or not at center. What about electric field strength? Anybody wants to answer? Electric field strength, will it increase or decrease? EP dash. EP dash should be equal to KQ by X square. X will be less than R. So therefore, EP dash will be greater than EP. So what happened to the field strength at point P on the surface will increase, but what happened to net flux through the surface will remain same. Net, I'll use word. Able to understand now? So now what is telling? So what is the electric, what is the flux through a surface? It depends upon the net charge enclosed by it. Where the charge is present, irrespective of it. What is the meaning of this? How many lines of force? So you count it. How many lines of force that were passing through the surface? The same number of lines of force are passing. So I need not to change. So the flux will remain same. Getting the idea? Now, so what? It is a small q, no? Small charge. Next, what I do is instead of point charge, sir, shall I keep any other charged body? Still, will you justify your answer? Yes, it will be. Anybody wants to ask it out? You can clarify it. And the same one more condition, I'll bring it. I'll keep that surface somewhere here. Now, where is the Gauss? This later we'll call it as a Gaussian surface. Let me write now only. Some imaginary surface. Now, what is the electric flux through it? Please do answer. You should answer no. Spherical surface or Gaussian surface? Both are same. No. I'll bring both the diagrams so that it'll be easy for you. Yeah. I think you are able to see the complete. Okay, compare this and answer it now. Let me have water. Anybody, can you answer? In third case, flux. No, third case. Flux is 0. Okay, Maya. Will be 0, no? How many lines of force are entering? Those many are leaving. 1, 2, 3, 4, 5. These lines they are entering and leaving. What is the net flux? Will be 0. So now what we can write? Getting some picture. How many lines of force are entering? Those many are leaving. So definitely the net flux. So now I'll change the surface from like a Gaussian spherical surface to any arbitrary shape. Then also, irrespective of that, how many lines of force are entering? Those many are leaving. I think you can look at here this part. Here the lines of force is entering and leaving. I'll magnify it. I'll come to the only the third diagram. Yeah, let's get into the discussion of this. You can see clearly how many lines of force. One, it is entering and leaving. Here entering, leaving. So how many are entering? 5 are entering, 5 are leaving. So net flux will be 0. Don't think yes, sir, here entering and leaving. It's a, this everything. This is surface here. This everything is a surface. So here they're entering, they're leaving. You should not take in this way. Some are asking, sir, here entering, leaving. No, this is the surface. Huh? Outer surface is what? The concentration. Look at it, outer surface. All are living. So don't think that, sir, entering and leaving. Flux through a surface means how many lines of force are coming through the outer surface. There is a meaning of here. Getting you look at this outer surface here. Here entering, 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 entering. Here it is leaving. 1, 2, 3, 4, 5. But sir, are you sure that, okay, you do one thing, calculate E bar and S bar, E bar, S bar. You have to go for integration, calculate E bar dot ds bar, work out, no, the net flux will be 0. In the, from Gauss law is telling simple, the net charge enclosed by this is 0, flux is 0. Any reason for that? Because is there any charge enclosed by Gaussian surface? No, charge is lying outside, no. So what is the flux? Flux will be 0. You bring one more point charge, not only this. Now, what about the field strength at point P? Non-zero, no? The field strength due to this point charge, whether you imagine this Gaussian surface or not, the field strength will be there. So what is this Gaussian surface? What we brought? It's an imaginary surface which we have brought to understand the electrostatic field. Getting the idea? This is not like a physical entity. This Gaussian surface is not like a physical entity which is present. Whether you assume this or not, what is the field strength at point P? KQ by R square. But what is the flux through this? Will be 0. Okay, now you bring this point charge inside, as the field strength will change. The flux will be non-zero. Let's take the another one. So I have a, let me take the thin Gaussian surface. There are 3 point charges, Q1 minus Q2, Q3 plus Q4. What is this? This, let me call it as a Gaussian surface. No, flux due to, I'm going to ask you very generalized questions. Net flux to the Gaussian surface. Net flux will be there only due to Q1, Q2. Because again, what all you draw the lines of force due to all the system of charges, only due to these two, what happen? The net flux will be there. So the net flux is given by Q1 minus Q2 by epsilon naught. Now, what about the field strength at point P? Who will contribute field strength at point P? Field strength at point P. Due to all EPs due to all point charges. The field strength at point P is due to all the surfaces. And now there's a net flux. Net flux is only due to enclosed charges. So I'll write the statements. Then later on I'll write it. This is the one thing. Field strength at point P is due to all charges. I'll write description. This question asked in advance because he just wanted to give the a very basic picture about the flux one. So first, electric field at point P is due to all charges. Okay, fine. Next again, flux through the surface is non-zero due to all charges. Net flux is due to only Q1 and minus Q2. And how much it is equal to? Q1 minus Q2 by epsilon. Now, what do you mean by this? So it's really, the second sentence is very dangerous. Sir. You can look at once. He's saying flux due to all point charges, non-zero. So there'll be lines of force due to this. There'll be lines of force due to this. There'll be lines of force. So what I suggest is that draw a lines of force. So I think you know how to draw the lines of force. So for these 3 point charges, draw the lines of force. After that, you have a Gaussian surface. Then how many lines of force due to Q4 are entering? Those many will leave due to Q4. How many lines of force are entering due to minus Q3? Those many will leave. Fine. But due to Q1, only it will be entering. Due to Q2, only it will be leaving. Due to Q1, only it will leave the surface. Due to Q2, it will enter. The resultant of this will be the net flux. So flux due to all the charges through the surface will be non-zero. So this Gaussian surface is what? An imaginary surface what you have drawn. And net flux is what? Only due to enclosed charges. What is the enclosed charge? Q1 and Q2. So Q2 is negative, Q1 is positive. So Q1 minus Q2 is what? The net flux. So we will contribute the net flux, the net charge enclosed by the Gaussian surface. Now I'll move this Q2 minus Q2 somewhere here. Then also net flux will be this much only. But the field strength at point P will change because the position of point charges will determine. No? So this shows that the field strength is due to point charges. It is irrespective of position of Gaussian surface. What about the flux? Flux depends upon only the net charge enclosed. Where the point charges are there inside the Gaussian surface, we need not to bother. Getting the idea? This one, if I shift minus Q2 somewhere here, then also the answer will be same. But the field strength at point P will become some other value. Like previously already we have discussed. And now this Q3, I will move like this. This will not change. This will change. The field strength at this point will change. But net flux will be Q1 minus Q2 only. Getting the idea? This one? These are some very good questions that are asked in advance. So a student has to really, the basics of Gauss law, what do you mean by flux, everything has to be understood. Any doubt you can clarify? Any doubts if you have, you can clarify. Because rest all mathematics, only the initial, the theoretical idea, you must understand clearly. Rest all everything is mathematics. The total Gauss law mathematically you can handle it.